Here are some examples on how to do projectile motion problems in the area of physics. And let's read the problem together. It says here that a boy stands on the roof of a 50-meter tall building. Something I personally would not recommend, but for the sake of the problem, let's continue. And he throws a baseball horizontally at 20 meters per second away from the building. Okay, I think I can picture that. How far away from the foot of the building will the ball land? All right, that's a pretty typical problem. How do you solve something like this? Well, of course, what you do need is you do need the equations of kinematics to help you out. In this particular case, the top two of that set there are probably the ones we're going to need. So make sure you have those available. And the first thing you want to do when you solve a problem like this is draw a picture of it, because mentally we can solve a problem a lot easier when we can visualize what's going on rather than just read a bunch of text and try to figure out what's going on from that. All right, so let's draw the building. There, let's say the height is 50 meters. So on top of the building is the boy. He throws a baseball out horizontally at V initial equals to 20 meters per second. And then we can imagine when you throw a ball out like that, that gravity will take hold of the ball, start pulling it down, start accelerating it downward, and eventually the ball will hit the ground at some point like that. And that would be some distance x away from the building. And that's the question they're asking for. How far away from the building will the ball land? So the givens are the height of the building, the initial velocity of the ball, and the question is how far will the ball land away from the building? All right, the next thing you do is you need a strategy. How do you start a problem like that? And normally, not all the time, but typically, for any projectile problem, if you figure out the time in the air, you're a long ways to solving the whole problem. So normally, the strategy would be, what is the time in the air? And the equation you need to figure that out would be the top equation right here, because remember, in projectile motion, the horizontal component of the velocity and the vertical component of the velocity are completely independent, and it's the vertical component of the velocity that determines the time in the air. So using the equation, y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. Remember, in the vertical direction, the acceleration is always due to the acceleration due to gravity, and g there would be a minus 9.8 meters per second squared. All right, final height, initial velocity in the y direction, and g here minus 9.8 meters per second squared. So let's plug in what we know. Final height, well, when the ball hits the ground, final height is 0. Initial height, starting from a height of 50 meters, plus the initial velocity in the y direction. Now, since the boy throws the ball out horizontally, there's no vertical component to the initial velocity, so therefore that would be 0. 1/2 times a minus 9.8 meters per second squared times t squared. Now notice here, the only unknown in this equation is the time in the air. And so we can solve for that, simplifying this equation. You see 0 equals 50 meters, minus half times that is minus 4.9 meters per second squared times t squared. Bring in the 4.9 over to the other side. We now have a positive 4.9 meters per second squared times t squared equals 50 meters. I need a little bit more room, so I'll move over here. Okay, next we're going to divide both sides by the 4.9 meters per second squared to isolate the t squared. So we now have t squared is equal to 50 meters divided by 4.9 meters per second squared. Notice that the meters will cancel out and the 1 over second squared in the denominator turns into second squares. We now take the square root of both sides, so this is equal to the square root of 50 over 4.9 times second squared. And so t equals, and grab my calculator here. So I have 50 divided by 4.9, and taking the square root, we get t equals 3.194 seconds. I grabbed an extra significant figure here just to make sure I don't have a round-off error in my final answer. All right, now we know the time in the air. So the next we're going to do is take that information and plug it into the same equation for the horizontal component of the velocity. So now we grab the second equation where x, the final distance covered, equals the initial position where we were when time equals 0 in the x direction, plus the initial velocity in the x direction times time, plus 1/2 a in the x direction times time squared. Now, for a projectile motion, unless there's some force acting on it in the horizontal direction, there will not be an acceleration, so this goes to 0. And the initial position when time equals 0 was at the edge of the building, so that was also equal to 0. So this equation simplifies to the final distance covered equals the initial velocity in the x direction times the time in the air, which we got from the first part of the problem. So plug in what we know. The initial velocity in the x direction right here is 20 meters per second. Multiplying that times 3.194 meters per second. And working that out, my trusty calculator here, 63.9 meters. Notice that the, I made a mistake here. This is time, not meters per second. This is second. Good thing I put in the units so I can check myself. But notice that the seconds here cancel out the 1/seconds there. I'm left with meters. And there's my final answer. Distance covered by this projectile, 63.9 meters. So quick recap. Straightforward, simple projectile problem. Something thrown out at a horizontal direction. You first figure out time in the air using the vertical component of the velocity. In this case, the initial velocity in the y direction is 0 because the ball was thrown out horizontally. You figure out time in the air, use that in the second part of the problem where you now use the horizontal motion of the problem to find the answer. All right, so let's do another one. In this case, it will not be thrown horizontally and see how that changes the problem.